All right, so we're kind of wrapping up our solving quadratics. Like one of our second to last method we're going to look at is solving quadratics by completing the square today. Keep in mind, and we'll kind of put this together, but when we're solving quadratics, remember graphically what we're figuring out is where it crosses the x-axis. So like when we get our solutions, that's really what it's telling us. So I mean, one easy way to check your answers with these is if you want to type these equations into Desmos, you could just check, do your answers cross where what you got? Like if you got x equals 2, x equals 5, check your graph in Desmos, make sure it crosses at those two locations. The only thing you got to be careful about is if you get imaginary solutions, which sometimes we will, they're not going to show up in Desmos. So that's one thing you can't really check graphically, but you can check your real solutions that way. A couple warm-up questions. The first thing when you're solving quadratics, because these ones we're not going to complete the square, we're going to solve by factoring. Is one thing that's worth checking is if you get everything to the same side, see if you can factor it like our normal way. Like for example, like since our coefficient is 1, what would multiply to 45 and add up to 14? What am I writing? So that would actually be 9 and 5. So that would be x plus 9, x plus 5. Doesn't matter what order you put them. So our solution, if you solve those, remember it's like what would make those equal 0? That would be -9. That would be -5. Because remember, you take the, like once you get it factored, you set each one of these equal to 0 and solve. So that's how I got these answers, if that's not clear. So that's a little bit of review. We looked at solving by factoring, I think, early last week. The notes are up if you need a refresher. Same idea here. That would be x squared minus 6x minus 11. Ooh, this one doesn't work. At least like how I was thinking, well, how could you solve this? Oh, this one's a little bit tricky. Oh, they wanted you to solve these differently than how I did. Cross out this example. I mean, I'll put it in the notes, but I think it honestly will be more confusing. You could factor what's here to start. Like that would be x minus 3 squared equals 20, and then you could solve this. Or I'll do it. It might actually help with what we're doing. Sorry for not being clear. But you could, like this, what multiplies to 9 and adds up to -6 would be -3 and -3. And then we could solve this using the square root property, square root both sides. So you'd have x minus 3 equals plus or minus the square root of 20. And then to solve this, you're going to use your, I mean, I would just use your calculator to get the decimal. You could reduce it. If you want to keep it in radical form, I'll leave that up to you. Personally, I don't really care. Ooh, I'll have to check if Delta Math, though, if they're picky. That's the only thing I didn't really consider. But the square root of 20 is approximately 4.47. So to get our two solutions, since it's plus or minus this, you're going to add 3 to positive 4.47. So God, I write too big. But you're going to get x equals 7.47. Didn't leave myself enough space. And then you would add it to the negative version. So negative 4.47 would be negative 1.47. So basically, like if you have a plus or minus, you add the 3 to both of those to get your two solutions. So Brooklyn asked, like, where did the 6x go? I just factored this trinomial, like what multiplies to 9 and adds up to -6. It's a perfect square trinomial. So that would be -3 and -3. So that's why it's x minus 3 squared, if that makes sense. Sorry, I just saw that. I know you probably asked that earlier. Oops, I didn't erase those. But let's kind of these questions, they're kind of showing you what it's going to be like when we're completing the square. So let's look at some examples. Let's kind of see like what our focus is going to be today. I know that example 2 is probably a little bit strange, but we'll see kind of why. they're asking, like they're showing you that. Because when you complete the square, you're going to see kind of that's what a lot of your problems are going to turn into. But so the first thing we want to do is rewrite our equation in this form. Basically, we want to move, like when you're solving by completing the square, you want to move your constants to the other side of your equal sign. If you have a coefficient with your x squared, you want to divide it out. So you no longer have it like in front of your a. So you would divide, like if you had 2x squared, you would divide everything by 2. Then we're going to complete our square. We're going to factor it like we normally would. Whatever you get, you have to add or subtract it, like to cancel it out on your equation. Then we'll take our square root and solve both of our equations. So let's jump into a problem. Let's see. One thing when you're doing these questions, like, I mean, unless they're telling you to, you're solving by completing the square, you should check, like, is there anything that multiplies to 56 and adds up to -18? Like, if you can solve it by factoring, like we saw in that first example, it'll save you a little bit of time, but I'm gonna like ignore checking those. There might be some problems that would work out a little bit easier, but I'm just gonna do all of these problems by solving by completing the square. But it is worth checking to see if you can solve it by factoring, like what multiplies to 56 adds up to -18. Because if that is possible, you can save some time. But remember that method won't always work. Like for example, I don't know if there is something that multiplies to 56 and adds up to -18. I actually don't think there is, because it would be 4 and 14. 4 and 14. Okay, it would actually. I think there is a way for this one, um, but I'm going to do it by completing the square. So the first thing we want to do is move our constants over. Usually I'm going to just leave a little bit of space and set it equal to what we had, so -56. So this is like that bell work question or the warm-up question we looked at today. So to complete your square, remember that's that b over 2 squared. So in this problem, that would be -18 over 2 squared, or really 9 squared. -9 squared, which doesn't matter when you square it, turns positive. So that would be an 81. So we're going to put a plus 81 here. Since we have an equation, we're going to do the same thing to both sides of our equation. So I'm actually going to add the 81 on the other side. I know usually we would do the opposite. That's because we were on the same side of the equation when we were doing these before. Like when we're solving, since we have an equal sign, we do the same thing on both sides. So you don't have to do the reverse or the opposite when you're solving. I mean, if you wanted to, I mean, like if it just makes you feel better, I mean, you could put a -81 on this side, but we really don't want to. You want to put it on the other side with the constants. Oops, I need to erase that. So now we can factor this trinomial. So like what multiplies the 81 and adds up to -18? Well, it's going to be not -9 and -9. Or remember, it's what's inside of here when you divide this. So that would be -9 before you square it. And then -56 plus 81, that would be 25, negative or positive 25, yep. So then we're going to solve this. So we're going to square root both sides. Just remember, when you square root in an equation, you got to put a plus or minus with your answer when you square root like a number. So then when we're solving this, I'm going to add 9 to both sides, but keep in mind, we're going to get 2 answers. So you're going to do +5 plus 9, which would be 14, and you're going to do -5 plus 9, and that would be +4. Because I really don't have a lot of space. I'll erase this, because really what we had, x minus 9 equals plus or -5. That's really, you really have these two equations if you want to rewrite them. I write too big. Like, so I usually don't rewrite it myself. I just kind of like just do them separately, like in my calculator or my head, if it's not like messy decimals. But 5 plus 9 is 14. -5 plus 9 is +4. So that's, but you like when you're solving these, you should always get 2 answers for these. I mean, it is possible to get the same answer twice, but I mean, for most of the problems you're going to see, you're going to get 2 unique answers. Um, and it is possible for some of these problems, you could even get imaginary or like solutions with I. Like for example, if you have an equal and negative number, but we'll see some of the problems we'll get to will be like that. All right, so number 4, it's already in this, like if you look at those steps, it's already in this form. So we don't have to do anything there, but we do want to get rid of this a, like we don't want that 2x squared. Because the reason we don't square root the number in the parentheses is because like that's x minus 9 squared, like the whole thing's up to the second power. So when you square root that, it just cancels out the power. Like you don't actually mess with anything on the inside, if that makes sense. Um, but I'll talk about that if that doesn't make sense. For 4, the first thing we want to do is deal with this 2. So we're going to divide everything by 2. And hopefully it divides evenly, because if you get fractions or decimal, it can get a little bit messy. And usually when that happens, like if I'm getting decimals, to be honest with you guys, I usually just use a different method. We'll learn about completing this, or sorry, quadratic formula. So I usually use quadratic formula if it looks like completing the square is going to be messy. I'll be honest, I usually, completing the square is not always my go-to method. A lot of times I'll just use quadratic formula, but it is important that you understand how to do this, because you might have teachers that tell you have to use completing the square like in a certain situation. So it's I want to make sure you're at least comfortable with it, but a lot of times there are alternatives if your problem gets really messy. But now we're ready to actually complete our square. So I'll just b over 2, that would be negative 8 over 2 squared. So that would be negative 4 squared. That would be 16. So I'm going to add a 16, and I'm going to do the same thing to the other side of my equation. So we don't have to do the opposite, because we have 2 sides of the equation when we're solving, if that makes sense. Like if you don't want to change an equation, you do the same thing to both sides. So I'm going to just erase this so it doesn't get in the way. So now we can factor this trinomial. So what multiplies to 16 adds up to negative 8? Well, that would be minus 4 and minus 4. And then negative 15 plus 16 would be 1. So then we're going to solve this. So similar to what we just saw, this is basically when you get to this part, it's going to be kind of the same way you solve. You're going to square root both sides. That just cancels out this power of 2 on the left side. So you just write what's inside your parentheses. The square root of 1 would be plus or minus 1. And then we want to solve this. So I would add 4, and I'm going to add it to positive 1. So that would be 5. And I'm going to add 4 to negative 1, and that would be 3. So you add it to both the plus and minus of what we had there. Aslan asked, what happened to the original 2? If you have a coefficient, I'm assuming you're talking about this. Let me know if you're not. If you have a coefficient, you want to divide it out. So you want it to be like problem 3, where you just have x squared by itself. So if you do have a coefficient, you just divide everything by it. And hopefully when you divide everything out, it divides in evenly. Because if you get fractions and stuff, it gets kind of messy. No. So yeah, so like for these types of problems, we don't really have to mess with that. Well, you could in theory, and then you could divide it out. But honestly, I would highly recommend you do it like how I'm divide it out first. It'll make your life easier. I think you could do that, Aslan. Like pull it out later and then divide it when you're solving. But I think that would be a little more confusing. Where did the 16 come from? Sorry, I had to erase it because I was running out of space. That's where you do the b over 2 squared. So negative 8 over 2 squared is 16. So that's where that came from, Michaela. I'm going to pause the recording just so resume recording. All right, let's look at 5. Okay, I'm going to do 5 and 6. And then I'm going to skip a little bit, and I'm going to do one of these last ones just so you can see some imaginary solutions. I'll probably skip problem 7 and 8. I'll check it out. So for this one, it's already in that form, like ax squared plus bx equals c, but we do want to divide this coefficient out. So I am going to get a decimal for that last part. Luckily, it's the end, so it's not going to really mess with my completing the square process. I'm going to write the decimal. You could keep it as a fraction if you like. It shouldn't really matter. But now we're ready to complete our square. So you do your new b. So that would be -2 over 2 squared, or that would just be 1. So I'm going to add a 1 to both sides of my equation. So I can factor this. So like what multiplies to 1 and adds it to -2? Well, that would be -1 and -1. Or one tip, it's always what's inside of here before you square it. Like if you simplify that. -0.75 plus 1 would just be 0.25, or 1/4 if you kept it as a fraction. So now we're ready to solve this. So we're going to square root both sides. You probably want to just put this in your calculator. You could do the fraction too if you have a calculator that does fractions, like the square root of 1/4. But you should get that it is 1/2, or 0.5 when you do that. Basically, what times itself gives you 0.25? Well, that would be 1/2 and 1/2 multiplied together. But you should get this either with a fraction or a decimal. Let me check the chat. There's a few messages. Oh yeah, sorry, my negative is here. Yeah, sorry about that. So then we just need to solve this. I'm running dangerously low on space because I write like a child. But 0.5 plus 1 would be 1. Okay, this is a disaster. Okay, let's retry that. So positive 0.5 plus 1 would be 1.5. And then negative 0.5 plus 1 would be positive 0.5. So those would be my two solutions. And you could check if you plug this into Desmos to graph, you should see that it, like on the x-axis, it crosses at 1.5 and it crosses at 0.5. I'm going to skip problem 6. It's a messy fraction. And I'll have to check in Delta Math to make sure they work out pretty nice. But honestly, because I'll show you, like if you divide this by 3, oh, well, first you'd want to move that 8 over. Like, so you'd really have this, sorry. But if you try and divide everything by 3, you're going to get tons of decimals, like, especially on the left side. That's what I'm worried about. Because, I mean, 10 over 3x, like it's not that big of a deal if you get a decimal like here for your constant, but when you get a decimal and you're completing the square, you're going to have to do 10 over 3 over 2 squared. You're going to get like you can do it. Maybe I can show you. But quite honestly, if I see a problem like this, usually I would just probably use quadratic formula, because the fractions usually throw off a lot of times throw off students. I'll post it when I post the notes if you want to see how to deal with it. But honestly, if I saw a question like number 6, I would probably use quadratic formula, which we haven't talked about here, but you probably have seen that before. I'm going to skip 7 and 8. These ones, let's look. I mean, 7 works out okay. I mean, your answers are decimals and stuff. 8 works out okay, but I mean, you get decimals and stuff. But I wanted to look at 9 and 10 because we're actually going to get imaginary solutions. So maybe I'll at least do number 9. But number 9, like I said, you want to get it in that form. So you would subtract the 43. I'll leave a little bit of space. So you want to complete your squares. So half of 12 is 6. 6 squared is 36. So I'm going to add that to both sides. So what multiplies to 36 and adds up to 12? Well, that would be 6 and 6. Negative 43 plus 36 would be -7. So right away, I have something squared equals a negative number, and I'm about to square root both sides. So right away, like Your alarm should be sounding in your head. Square root negative, square root negative. You're going to get imaginary solutions here. If you ever get a negative number, like on the right side of your equation in this process, just keep in mind, you're going to have i's in your answer. So we're going to square root both sides. So that's just going to be x plus 6 because that cancels out your power of 2. But on the right side, I mean, I personally, I mean, I'm just doing the decimals. I mean, that's not going to reduce anyways. You could, I mean, you could keep it as the square root of 7i if you want, but I'm especially because most of the time we're doing these, we want to see actually where it crosses. But I put that in my calculator. I got about 2.65 is the square root of positive 7. And remember, that negative means we're going to put an I with your answer. So make sure when you put that in your calculator, don't put in the square root of negative 7. You're going to get an error. Just put the square root of positive 7 and then put that I after your answer. And I should also be careful. I need to put my plus or minus. So I'm going to subtract my 6. And we can't really do much with this. So my answer is, and usually you put the real part first and then the imaginary, it would be negative 6 plus 2.65i. And then my other answer would be negative 6 minus 2.65i.